Stephen?
We appreciate all those who participate in the awards. It's a lot of work, but it gives some great recognition to your company, and we'd invite you to be involved next year. I do want to thank, like Rajiv did, all of you for being here. I love being part of TDWI and look forward to bigger and better things as we continue to grow and implement some of the new things that we're working on very hard at TDWI. Right now, though, I'd like to turn the time over to Kurt Brown to give his keynote address. Kurt leads the data platform team at Netflix. His group architects and manages the technical infrastructure underpinning the company's analytics. The Netflix data platform includes various big data technologies like Hadoop, Spark, Presto, and Pig, Netflix open source applications and services like Genie and Lipstick, and traditional BI tools from Teradata, MicroStrategy, and Tableau. So please give a warm welcome to Kurt for being here with us today. Thank you.
Thank you. Okay. Thank you for the introduction. I'm going to talk about data platforms today, fortunately, because that's what I know something about. What I'm really going to talk about is how to get the most out of your data platform. So technology, obviously, is very important, but there's so much more to squeezing every ounce out of your data. So if you don't know what Netflix is, then I don't know where you've been living, maybe in Mongolia. But if at a really high level, if you don't know what it is, we're primarily about streaming movies and TV shows. There's a lot more to us, but that's the gist of it. What you might not know, though, is that over 1/3 of North American internet traffic at peak is Netflix. So that's all the bits and bytes that you guys are watching at night, not clogging up the internet, but sort of making everyone happy. That equates to over 100 million hours of Netflix watched every day. This is actually around the world. We now have over 65 million members in over 50 countries. And then outside the US, it's streaming only. So if you're one of the old DVD diehard fans, sorry, you have to either live in the United States or move to the modern world. So at Netflix, what is big data? So this is our world of big data. We get about 500 billion, actually more than 500 billion new events every day in our data warehouse. So this is what brand new events, they come in through our data pipeline, they get processed, and they get added to over 15 petabytes of information that's stored in our S3 back data warehouse. And I'll talk about that in a bit. So what kind of data am I talking about here? This is anything about Netflix. This is what movies did you stream? What is the quality of experience you're getting? How are you interacting with the UI? What are you searching for? Anything that we can sort of tease apart to figure out how can we give our customers a better experience. And a lot of you know, but probably some of you don't, that just about all of our infrastructure runs in the Amazon cloud, which people often think we're crazy for because Amazon, video, Netflix, isn't that a competitor? But it's worked really well for us. They're different companies. And it's been a huge enabler. We started as DVD in a data center, and we are global now. If we had to do this in a data center world, it would have been really, really painful. So just about everything is out of the data center. We still have this sliver of billing. I keep saying it's just about out of the data center, and it's just about out of the data center, but it's not quite out yet. And once that's out of our data center, which should be this year for sure, then we will have no more data center presence at Netflix. So what does this data platform look like that I've been talking about? So at a really high level, we have a lot of application servers that are interacting with client devices. They're the things that are saying, hey, here's Netflix, here's what the user's doing on their devices. And all those devices, in addition to serving the Netflix experience, they log a lot of data. And how do they log that data? They log it down a pipeline called Kafka. They actually don't log it down a data pipeline called Kafka because this is not quite true yet. So in 1 month, it'll be logging down a data pipeline called Kafka. So right now, we actually log it down a pipeline called Suro. And I'll talk about why we're switching to Kafka over the course of this presentation. But at a really simple level, Suro is something that we built in-house. We had to a long time ago. There was nothing that could deal with the volume we had, or at least the things that were there. There was no clear winner. So we took a project called Apache Chukwa. We hired one of its inventors, and then we slowly over time turned it into something that would work really well for our volume. But Kafka has taken the data world by storm. No pun intended, if you understood that pun. And it is pretty much the de facto choice for big data for data pipelines at this point. And it has a huge community behind it, and that's always a good thing. If you're the only person that's doing something, you're probably going to be doing a lot more work than if you can lean on other people's good efforts. So anyway, so Kafka will be our main data pipeline. 500 billion events will be flowing down Kafka. It's going to simplify our architecture. It's going to give us the community support that I was talking about before, and it's going to give us better durability than we have right now. Now, S3 is kind of weird. Like, I haven't even shown a data warehouse, but this is actually our data warehouse at Netflix. So S3 is like an infinitely scalable, infinite in quotes, object store in Amazon. So we land all the data there. We have metadata on top of it, and that is what we consider our data warehouse. That's the 15 petabytes that I was talking about before, and then we do all sorts of stuff with it after it lands there. So in addition to all this event data that I've talked about, we also need dimension data. So what are you a member or are you not? What A/B test cells are you in? We need to get that from some system that is what our application servers are using to validate users, et cetera. So all that is Cassandra. We used to have Oracle in our data center, but we want to make sure all of our systems are distributed, large-scale, or horizontally scaled systems. And Cassandra's a really good choice for very fast reads and very fast writes. What it's not good at, though, is arbitrary queries, which is exactly what we do in data analytics. So it's a poor choice for a data warehouse, and we needed to get the data out. And unfortunately, with Cassandra, the reason it's so fast is you model your data structures for exactly the kinds of queries that are going to be asked, like, are you a member or are you not? Now, we wanted everything out. So we had to create a process that we called Aegis, which takes the data in bulk out of Cassandra and puts it in S3. And why the terrible name Aegis? Well, the guys in my team that developed it were getting so frustrated with Cassandra. They tried all sorts of things like running Hadoop over Cassandra and all these things to get the data out. And they finally figured out a way to do it just using the actual files underneath Cassandra. And they looked on Greek mythology, and Aegis was the person that killed Cassandra. So the Cassandra team wasn't too excited about that, but it makes for a good story. Now, once the data is landed in S3, so you have this event data through Kafka, you have the dimension data from Cassandra through Aegis, you need to do something with it. So our ETL language of choice is Pig and Python that runs on top of Hadoop, and that lets us process this massive amount of information. Now, just stepping back for a second, the reason that we're using a lot of these technologies is we're dealing, obviously, with huge scale. If we were dealing with small sets of data, this would be absolutely overkill, but this is the reality that we live in. In addition to doing the ETL with Pig and Python, people want to query the data. We've had Hive in the mix for a little over 5 years now, and it's great. It's a workhorse for doing ad hoc analysis, but it's really slow. It's getting faster over time, but it's nothing like a relational database, which ties into a subset of information. So I said S3 is like our Uber data warehouse, and a subset of information we push down into Redshift and Teradata, and that lets us get a faster performance and also gives us good integration with third-party reporting tools. So we heavily use MicroStrategy and Tableau as our enterprise reporting tools. And in addition, we created our own sort of custom technology called Sting. And I'll talk about it because it starts touching into a big part of my presentation, which is philosophy behind how we do things. So the reason we invented Sting is that a bunch of our engineers were like, MicroStrategy is too hard, Tableau is too hard, anything is too hard. They just want to go into a web page and be able to write a query and then say, I want to slice and dice the results like sub-second time. Now, obviously, MicroStrategy and Tableau, they have tons and tons of additional features. We wanted to keep Sting ultra feature light, ultra intuitive, and that's what it lets you do, is you can write a Hive query, which takes a fair bit of time, but then it every day can run over and over and over, loads the data in memory, and then you can slice it and dice it. What's interesting about it is that we've been asked for a lot of features for Sting over time, and we say no. And it's not that we don't want to do good things, like we want to make the platform the best it could possibly be, and we know we could, but the positioning of Sting is to be lightweight and intuitive. As soon as we start adding more and more features on top of Sting, it becomes MicroStrategy and Tableau. It's not intuitive anymore, and then people won't like it. So we have to sort of hold the line, and as long as we're clear on that's the positioning, and there's alternatives. It's not like, oh, sorry, you can't do your reports. It's go to one of these other tools, or actually the way Sting is written, you could create your own front end on the back end. People haven't done it yet, but we have the hooks to do it. We're just saying, keep it simple, stay with your vision. Another technology we added into the mix almost 2 years ago is Presto. Again, if you're dealing with technologies like this, I highly recommend looking at Presto. It came out of Facebook. It's another querying engine for ad hoc data. and it's much, much faster than Hive. So it's a totally different architecture, but it can use HDFS or S3 as a backend. It can use Cassandra. It can use all sorts of different backends. And it's fairly ANSI SQL compliant. They're purposely trying to stay out of the ETL game, so they don't have even some basic things like UDFs or stored procedures, but it's really good for ad hoc querying. And it's been a huge blessing for us. There are limitations. They might sound like funny limitations, but like no more than 10 gigabytes of memory per query or 2 terabytes across our cluster. But we crush against that all the time, actually. And then what we say to our users is, if Presto doesn't work, then just use Hive. More recently, we also added Druid into the mix. So Druid it's a totally different slant in terms of a data platform capability for us. So all these other ones are very flexible. So you can use Hive or Presto or Pig, and you can join data arbitrarily at runtime. Druid is you have to pre-ETL the data that you want, and you land it somewhere, and then you get interactive response time. So it's sort of like Sting, but on steroids, and we're actually going to probably move Sting into Druid at some point, where what's nice about it though is it can deal with a huge scale of data and it can do it really, really fast, but you just lose the flexibility that you get with these other tools. So there's always a trade-off. Flexibility, speed, and scale, you cannot have all three in full. You have to make trade-offs across those 3 dimensions. And notice I didn't even say cost. Cost might mitigate some of those things, but it can't make it go away. And then Spark is the darling of the industry right now. If you're in data platforms, you've certainly heard of Spark. You might have been playing with it, or someone on your team certainly is. It is huge promise for it. We started looking at it a few years ago, and it was cute, I would say, back then. We put like an hour of data from one of our biggest tables into Spark and tipped it over without even trying. But now, like fast forward to now, we have about 6 lightweight production Spark clusters running across Netflix. Some are doing algorithms, some are doing stream processing, and then we actually have it running on top of Yarn, on top of Hadoop right now on the data platform that I manage. And we anticipate over time that more and more of our jobs are going to move off of Pig onto Spark. Spark is a very compelling platform for many reasons. One of the nicest things is it's a full ecosystem. So a lot of other things are really about one particular, like ETL. I'm all about ETL, or I'm all about streaming. Spark is about stream processing. It's about doing ETL. It's about doing SQL through Spark SQL. It's got machine learning. It's got graph processing. It's a similar syntax for all these different things that compile down to the same core engine. So that's a really compelling proposition. But the best thing about it is that it's the most active Apache project right now. So it's getting this community goodness that I sort of mentioned with Kafka behind it. So it's just going to get better and better and better as long as that momentum stays. And all the major Hadoop vendors have jumped onto Spark because they realize that its leveraging of memory lets it be much more efficient, let's say like iterative algorithms, than Hadoop could ever be. So the other thing that's nice about Spark is it's also a lot more language agnostic. So you can use Scala, which is the native language that it's written in, but you can also use Java, or you can use Python, or most recently you can use R. So who chooses these technologies? And this is a funny one for me, because I was actually in a conference and somebody asked this in the audience, and I was actually stumped for about a second. Because I'm like, well, like sometimes I choose them, but sometimes the people on my team, they choose those a lot, and then our developers, they choose technologies a lot. And as I'm sort of playing it through in my head, I'm like, that's how it should be. If I'm choosing the technologies, it's wrong. If any one person is choosing the technologies, you're doing it wrong. It has to be organic. It has to be based on needs and expertise and abilities and what you're seeing and the problems that you're facing. So it really is an organic evolution is the right way to go. But then why these? This is going to, there's a lot of words I promise will come on this slide. Because as I was thinking about it, I always wanted to say in a presentation like this that you should have the least number of tools possible to get the job done. And then I look at that last slide and I'm like, wow, I seem like a total hypocrite, or I'm a really bad data platform manager, one of the two. And really what it comes down to is that there really is a reason for everything there. We're very thoughtful about what we have in the platform and what we don't have in the platform. So on this slide, I'm going to articulate some of the thinking behind why we have what we have, and some of the thinking that you guys probably have done or should do when you're thinking about your data platform. So the first and the most critical is obviously business needs. If it's not meeting a business need, if it's just some shiny new technology, don't bother. There's better things to do with your time. The next is differentiating value, and this is even more so for new technologies. If you've got something in the mix and something new comes along, like we have Cassandra and HBase comes along, and you're like, what is HBase going to give me that Cassandra doesn't? In many cases, not a lot. So I wouldn't casually add HBase. Now that being said, like the Hive Metastore might move to HBase, so it might have to use HBase at some time, or there's other reasons that it might get forced into your platform, and those might meet business needs ultimately. But if it doesn't add a whole lot of value, don't just add it because it adds complexity. Scale is something that we obviously have to deal with that rules out a lot of technologies or rules in technologies up front, and sometimes we have to invest in those technologies to deal with the scale that we're dealing with. Expertise, you can't undercount that. If someone really knows a tool, they're going to use it effectively. And it's all about driving business value at the end of the day. Now, you don't want to hold so tight and go, I've got these great COBOL programmers. I'm going to keep using COBOL till the end of time. So at a certain point, expertise has to get outweighed by these other variables. Maintenance is also important. Each of these technologies has a cost operationally and also expertise and integration with the rest of the platform. So just having something there, there's a drag. So it really has to justify its existence. Contributions is very important, particularly for an engineering-centric company like us. We know that it's not going to meet our needs, a lot of these technologies out of the box. So we really like it when we can get in there and say, we have this problem, let's just fix it. And then that ties into, we don't want to fix everything. We want a community to fix these problems. So that's also important. That's where something like Presto was so important for us, is that, well, actually, I shouldn't say Presto. That's where Spark is so important for us, is that the community is so strong that we know that it's just going to be better and better and better. Legacy is also important. If you have a code base, just ripping and replacing, that can be quite an expensive endeavor. And the future is important. This is where Presto, I meant to say, comes into the mix, is that we were betting on it. So we bet on it 2 years ago. At any given point, it might be like, do I really want to put this in my data platform? But if you're thinking ahead of where you need to be, then it might make sense to make the investment. And the last thing, which is interesting, especially for business people and sometimes IT people, is cost. Cost is irrelevant until you've dealt with all these other things. It's not irrelevant like how much it actually costs. Like, I'm going to negotiate for the best cost I can get. But at the same time, if you don't meet these other criteria, it could be free, and I don't want it. It's just more trouble than it's worth. So I've talked a bit about technology. I started touching about philosophy, but most of the rest of the presentation is about how to think differently about a data platform and just how to do things. And at Netflix, we do things very different, as you'll soon see. So what I really like that drives, I think, all decisions at Netflix is what I'm calling the North Star. And that is our expense policy at Netflix. Or at least that's the nice distillation of how we think at Netflix. This is our expense policy. 5 words: act in Netflix's best interest. There's no, here's your per diem, and you can stay in these kind of hotels, and da-da-da-da-da-da-da. It's more like, we hire adults, and we expect you to do what makes sense and act in Netflix's best interest. So it doesn't mean like stay in some flea-ridden hotel because you're saving money for Netflix. You're not going to want to work at a company that does that. It's more like, we don't want to create rules and policies that tell you what all this stuff about travel. Instead, we just say, do what makes sense for us, and then we don't have to try to have committees and processes and all these things guiding you. You just be on your merry way. So how do you put that into practice? So one good example, I think, is it's really all about impact, not perfection at Netflix. So we're all type A personalities at Netflix. We all want things to be perfect, actually, but there's always these trade-offs, and you don't want to get lulled into the sense of perfection at the cost of impact. So a good example of this is our data pipeline. We have 500 billion events going through our data pipeline every day. It's easy to say, I can't lose any data, or I don't want any duplicates in my system. That's a very attractive sounding thing, but it's completely impractical. The cost of trying to make it a lossless or no duplication pipeline is so high that it doesn't justify it. And then if you have 500 billion events and it's 0.00 whatever 1% of loss, then you're not going to notice that anyway. It's just noise. So you should really be thinking about like how much effort are you trying to be perfect when it doesn't make any difference and you're using all this time and energy and cost when you could be spending it building other grander new systems. And this ties into another broader way of thinking about acting in Netflix's best interests, which is you should question everything. And I'm saying from a Netflix perspective, but if you can translate in your head to your own company, like, and you might get a lot of pushback, but show these slides to your boss, and I'll show you a culture deck at the end of the talk, which is really interesting. But what I've always found is that it's interesting how many processes you have in place that really don't make that much sense. But this is the release process. This is how we've always done it. And then even worse, sometimes there's one or two good reasons for it, but then there's a lot of really bad reasons not to do it, and everyone anchors on the reason. Well, it's because, because of security, or because, we have to make sure nothing breaks in production. And often that doesn't really make sense. It doesn't hold up. When you add it all together, you said, I could do it like this, or I could do it this other way. And maybe I trade off a little in the thing that you're anchoring on, but you get all these other great benefits for it. You should question it. You should always say, does this make sense? Don't just use inertia to keep doing the same things as has always been done. So an example of one of those things at Netflix, which is very different than how it works at most places, is that often we will tell people what we're going to do instead of asking people if we can do it. And this is definitely in the data platform team. It spreads across the rest of Netflix, but it's kind of a novel and scary concept to a lot of people. Like, we will say, we are upgrading on this date, our data platform. Your jobs are going to break. They should all have been built to automatically restart. And the nice thing is, if someone comes back to us and says, oh, well, hey, we're launching in a new country that day and the reports are super critical, then that's fine. Now you've told me that don't do it, and then I'll hold off on it. But if I'm waiting for you to give me the little sign off, I'm going to be waiting forever. And that gets back to that impact versus perfection. I've just undercut my impact a lot. If I'm waiting months and months and months to gather all these responses and coordinate, no. Make the change, break stuff, fix it if necessary. So you have to make sure you have good safety nets. You should have like auto retries, like all this stuff. So very rarely does it actually break things, but if it does, that occasional cost is so much less than the ongoing drag of waiting for approvals. Another timely, or not timely, well, timely, I guess, based on the slide I have here, but an interesting topic was from the last place I worked, 8 o'clock was this magical witching hour for getting reports out, and it just didn't make any sense. It was like hell to pay if 8 o'clock, if the reports didn't get out. What business decision was so dependent on 8 o'clock versus 10 o'clock? Nothing. And the cost is so high to make sure it gets done by 8. You have to have your source system teams on call. You have to have your data pipeline teams on call. You have to have your ETL engineers on call. You have to have your reporting teams on call. And then if they do get woken up in the middle of the night, like they're hosed. They're not going to have a productive day the next day. So you've just cut down the impact of what you can get done in your business to get a report out that was going to make no difference. So if you're really talking about data warehousing, most of the stuff, it's long-term trends and analysis. It just doesn't matter. So these are the kind of things that question everything. Like, does this really make sense? It's not that we don't have some people on call if everything goes off the rails in the middle of the night, but everything is not a crisis. Another topic that is on the question everything front is what I call the misuse of DBAs. And I was a developer back in the day, and I was even a DBA, accidental DBA, SQL Server. It's just so easy to administer. And I always hated it as a developer when you say, okay, here's my code, and you give it to your DBA, and you wait some indeterminate amount of time for them to release it onto production, and now you have to be on call because it might break in the middle of the night, or you're trying to coordinate with the release of a report at the same time, and they might mismatch, and it just becomes this big mess. And it's like, what value did that DBA add in that picture? Just about none. It was a net negative for the most part. It's intellectually attractive to think, oh, they're going to stop a problem from happening. But how often are they really going to understand the code that you just wrote, that you're an expert in? And if you're not an expert in it, you probably shouldn't be doing it. But if you are, then you should be able to release that code onto production. And maybe the DBA gets auto-notified that something went out, so if something does break, they can figure out what actually happened. Or maybe you do it during the day hours at least, or something like that. But what doesn't make sense is that you hand this code to them, and they're just code pushers. I have a couple DBAs on my team. They do not push code out to production. Our developers push code to production. What my DBAs do is they do optimization, and they operate the system, and they look at forward-looking architecture. And it's a lot more fun job for them, and the developers are more productive. So it's like, why are we doing it like we're doing it at so many companies? And this sort of distills down to what is the development and deployment flow at Netflix? So there's not that gate in the middle that it is at most companies, like a release team that you give all the stuff to, and again, wait, and there's a lot of back and forth. You can release your own code. Now that sounds like a scary equation, but then you add the stuff at the bottom and it can work. So I should say I'm all around it. So you have best practices at the beginning. So this is simple things like here's our naming standards just for some consistency. Here's how we recommend you do things. You don't have to do them that way, but if you do it that way, then it's probably going to work out better than if you just cowboy it and do it your own way. But it's best practices. It's guidance. It's not dictates. Then throughout the process of development, you have consultation. So developers can talk to my team. They often talk to their peers. Does this make sense? If it's especially critical, instead of having some central QA team, they can decide, hey, I should really get this reviewed by somebody else, by one of my peers. Or they can decide not to because it's so trivial. And at the end of the day, they're accountable for it. If it breaks, it's on them. So they should be able to make that decision. Then components is another thing. So instead of everyone having to do the code from bare bones scratch, we provide a lot of components that abstract some complexity for them. We have a lot of tools so that they can self-service interact with the platform. And then there's a lot of automation. So, put your shortcuts for MicroStrategy new releases to production in a folder, and then we automatically package it up and we push it into production for you. And then the cost is there's going to be some cleanup. So if you don't have a gate, then a lot of stuff is going to get onto the system, and you're going to want to clean it up at some point. Now, it's actually a false extra cost because you're going to have a lot of cleanup no matter what. Like even if you have this great release process team, junk is going to get out there. You're going to have to clean it up over time. Or even if it was the best thing in the world that was put on the system, it's going to rust over time as data volumes increase or something. So you need this cleanup step. And this is often neglected at places, and then everyone's like, why is the system so slow? So another topic which I think is interesting since I manage the data platform is thinking about whose data platform is it? Now, is it mine as the data platform team, or is it yours, meaning like the developers? And I think that if I think of it as being mine, I am absolutely doing it wrong. There's no reason, like if I say, this is my data platform, it's not my data platform. Like, it's only there to serve developer purposes. If they didn't have those needs, I shouldn't have a job. There's no reason for it whatsoever. So it's a dangerous mindset if I'm like, don't do this to my platform. Instead, what I want to do is I want to say, this is yours. It's your decision on how to do things. So for example, if you want to spend $10,000 for mapping software that you want to put on the data platform, who am I to say that that's worth it or not worth it? What my job is to do is to say, it costs $10,000. Is it worth it to you or not? And now that person is accountable to say, it is worth it or is not worth it, because I can't say. And that's a much more empowering for them, and it's much more reasonable for me. But in order to do that, you really need to provide visibility. If it's a black box system and nobody has any idea what's happening, then unfortunately I do have to own it. My platform team has to own the system because nobody can make sense of it without going to us, and then we go in the back room and type away on keyboard and say, oh, here's what's wrong with your job. You need to provide visibility so people can self-service figure out what's going on. And one example of that would be like, suppose it's not even your job that's misbehaving. Suppose it's your neighbor's job that's killing the system. You have a vested interest in whacking that person on the head and saying, optimize this job. And they might have the responsibility back saying, I got this other super critical priority. I can't do that right now. And at least that conversation has been facilitated by us providing visibility into the platform. And an example of visibility that we provide and something we open source is called InViso. So if you do use the Hadoop ecosystem, this lets you break down pig jobs. So you can see at the top, this is the different map-reduce jobs that are within a given pig job. You probably can't see it. You can look online. The slides are posted there. But you can also look at the specific map and reduce tasks that are executing. You can see things that are skewed that might be optimized, or things that are getting killed, which might show a bad node, all sorts of other statistics. But it's basically visibility into what's happening on the cluster at the job level. It also gives you higher level views of who's actually using the system, all these different colors or different users of the system. This might be where either maybe I would, as a data platform team, go, is something going wrong, like you're using all of the cluster? Or again, you might go to one of your peers and say, what the heck are you doing? Why are you running all this huge backfill jobs in the middle of the day? And then they might decide to kill it and then free up the system and run it over the weekend or something. And then the bottom shows backlog on the system, which means either, hey, you should optimize a bunch of jobs, or potentially we should get more hardware resources. But again, provides visibility. So we open sourced this tool, and this leads to another grand topic about open source. Like, why would we open source this? Is open source good? Is it bad? Is it bad for vendors? Is it just a tax on companies to actually do it and participate? So let's dive into it a little bit. So general open source technologies like Hive and Pig and Hadoop, and most of these, actually all of these, came out of one company or another. In this case, Yahoo and Facebook, these technologies came out of. the reason that open source is so great, and the thing about these projects is these are Apache projects now. No particular company owns them. But the beauty is it's pooled goodness. I mean, Hadoop is not the best thing in the world, but you have such a big community behind it that it's become the de facto choice for big data. And Spark, it'll be interesting to see how that interplays over time. Spark and Hadoop are kind of blurring anyway. As I said, we're running Spark on top of Yarn, which is part of Hadoop, and then a lot of times it gets run on top of HDFS, or in our case, S3, so it's all cross-mangled. But you get this pooled goodness of a lot of people contributing, so you get a lot more done than if you were just doing it yourself or if a vendor was just doing it for you. You also get the ability to manage your own destiny. So this is really important when something is broken, and you hate when you have to like talk to your vendor and be like, please, please, please get this feature in, and they're like, oh yeah, maybe we'll do it, and then 3 years later, please, please, please. So with open source software, you can make the change yourself, and that is very, very empowering. And then you can, ideally, you push it back into the open source. Sometimes you get pushback where people don't want it. You can have your own fork if you have to. It's a little expensive to keep applying the same patches over and over and over. So ultimately, you do want to get it back into the main open source trunk. The other thing that's a beauty about it is that it doesn't mean you don't have vendors in the mix. There are the Cloudaras and Hortonworks and MapRs, et cetera, out there. But the beauty is that it changes vendor relationships because you don't have to stay with them. It's not like, oh, I bought something and now I've got so much code there that I'm stuck. Instead, it's like, well, if you don't play nice with me, I can just take my code and bye. And it just creates a better partnership, I think, with those companies so that it really is an ongoing value add. Every day it makes sense and you want to continue with it. Now, the downside, obviously, there are going to be conflicting agendas. You are going to have, again, the MapRs and the EMRs and the Hortonworks and the Cloudaras, that they all have they want to differentiate in some way, which can make it a little confusing as a customer, or you get this feature, you don't get this feature. The nice thing is if they're all really playing in the open source world, that code ultimately gets back into the core base, and you actually, in some ways, benefit from the competitiveness that drives the project forward. So that's all well and good for a vendor and the community, but why Netflix? Why would we do it? I'm not selling you anything other than a video subscription for like $8 a month, which is probably not the best use of my time. But why would we open source technology? So the main thing is, first off, we are not going to open source anything that does not meet our needs. We're not doing academic open source because we want to get like our name out in the industry. These are things that meet core Netflix needs. And one of the reasons we want to do it is that it can create a sense of shared direction. By us putting this out into the ecosystem and other people adopting it, then we're all in the same train together. They are working on the same things we're working, as opposed to the Kafka case that I said before, where we had Suro, and we're going off and doing that. And granted, when we started with Suro, Kafka didn't exist. It certainly didn't exist in any open source sort of fashion. So we had no choice there. But now Kafka is this shared direction. So by us putting something out and it becoming the shared direction, then we're not going to have to pivot at some point and scrap our code, scrap our Suro code, and then move over to Kafka. We'll be that train that everyone's getting on. And especially in the Amazon ecosystem, we're a pretty big player, so a lot of our technologies are being adopted by other companies. It's also good for recruiting and retention. It's fun to work on open source, get your name out there. It's not something we espouse at Netflix. Like, it shouldn't be about that. It should be about what's good for Netflix, but it has this sort of halo effect. It also, a minor thing, it can be improve code quality just a little bit, because if you're going to have your code that a lot of people are looking at it, you're going to want it to be a little more polished than if it's like, behind the scenes. And then the last and big thing, depending on the project, could be contributions. So again, you're not the only person making the contributions. Other people can add to it as well. So on the data platform team, the team that I manage, these are some of the technologies that we've open sourced. I talked about Agathis and Inviso. I'll talk about one more, Genie. So Genie is an abstraction layer we put on top of Hadoop initially, where you as a client don't have to know about what's happening, where these clusters are. We have a production cluster and we have a query cluster, and you don't have to worry about it if we decide to blow away the cluster and replace it with another cluster. You just do a RESTful API call and say, here's the job I want to kick off. And that, I'll talk a little bit more about it later. It gives us lots of power and flexibility, especially in the cloud. And we've actually further abstracted Genie now where it's an arbitrary execution engine. So we actually can use it to send queries to Teradata or to Presto or just about anything. So our next question is, should you open source? Well, it depends. You don't want to put out junk. Like, that doesn't help anyone. Just say, yeah, I worked on this thing, and hey, community, take this thing. So first off, if you don't get value out of it, I can pretty much guarantee nobody will get value out of it. So don't bother doing that. The next is you might get a lot of value out of something, but it's very niche to your specific needs. If it's that niche, then great, keep it. But there's no reason to put it out there and have clutter your time and other people's time looking at something that doesn't apply. The other thing is you should invest some time, at least, if you're going to put it out there. Otherwise, it dies in the vine pretty quickly and can frustrate the community that you put something out there and then let it drop. And then a bonus tip is if you are going to open source, and this is something that we learned the hard way because we didn't plan on open sourcing a lot of stuff when we started it, is that it's best to think with a mindset of open sourcing up front. So design your systems so they can be open sourced. And it's actually a good design principle, period, because it lets you isolate your systems better. So you can say, oh, I'm just open sourcing this versus sort of the cross mingling that naturally happens when you're just thinking of it as I'm just trying to meet a Netflix need or your company's need. Another interesting topic, especially with some vendors in the mix, is should you buy or should you build? And here's my take on it. Is, well, if you don't have really strong engineering resources, you're pretty much going to have to buy. But there are times where even if you have the best engineering in the world, then it still makes sense to buy, and there's a lot of cases where it makes sense to build. So here are some considerations that I'd throw out and some warnings. And these are mostly geared around startups, but some of them equally apply to bigger vendors. So one of the most important things is, are you in their sweet spot or not? So if we're in the cloud, we're at huge scale, and if the company just doesn't do that, that's a dangerous place to be. Because the problem is, you're not going to get the attention and love that you need. And the worst part is that it actually makes sense for you not to get the attention and love that you need, because that's not where their core customers are. Now, sometimes if they're really forward-thinking and you're forward architecture leaning yourself, they might say, I really want to be there. And you're not, it's a little dangerous because it's the sweet spot that they want to be in. But bottom line, the more you're in that sweet spot, the better off you're going to be. Maturity is another big thing, especially with startups. Early on, they have grand dreams of all the stuff they're going to do, and you can write anything you want on a piece of paper or type it on a keyboard. But what actually materializes at the end of the day could be drastically different, especially as you start running it. A startup runs out of money, and they start pivoting to try to chase money from some company that says, if you just do this, I'll do that. It's a dangerous place to be in, and you really don't want to be the beta tester for lots of different startups out there. Another key part is, depending on how business critical it is, it's more and more dangerous to work with startups, because if you build your foundation on top of something that might pivot or go away, you could be left in a lurch. So if it's a side thing that adds a bunch of value to you, and if it goes away, that kind of sucked, then that's not the end of the world. But if it's like the core underpinning of everything, beware. I'd say the qualifier on it, though, is what they're doing truly differentiating? If it is going to add so much business value and simplify your world so much, and the promise is so far along, and their maturity is really getting there, then it starts being like, okay, it's a cost-benefit trade-off. So I'm not saying don't work with startups by any means, but truly I put in italics there is like I'm so differentiated from this other vendor, but a lot of them are not that differentiated. And if you're really taking a gamble, depending on how far along they are in the maturity cycle, then you want to make sure that it's like, I have to have this thing, and I'm willing to pay a little bit of testing cost and stability cost. And then the nice mitigator of all this stuff, again, is open source. So we really like working with open source companies because, if nothing else, if they do change, we do have the code. You're left in a lurch. We don't necessarily want to maintain all this code for all these different platforms, but at least it doesn't put you in a really bad position. But you do have to be aware of icebergs. So icebergs, I'd say, whether you're building it or buying it, it's the stuff beneath the surface, like, oh, just here's my tool and it does this, but it has all these other intangible costs until you get into it, like integration with the rest of your platform. So the way to avoid a lot of these icebergs is what I call the paved path. And this is my team's job, is to make sure that we provide an easy, seamless way for you to interact with the data platform. So you don't have all these icebergs that you hit. And it shouldn't be that you have to go down this path, this is the only way. It should be compelling. It shouldn't be a mandate. It should be like, well, of course I want to do it this way. I don't want to end up inventing my own wheel that is going to cost me a lot of time, and it's usually going to be a lot worse than what a bunch of people on a platform team, in conjunction with other developers, has said, here's a good way, and does it make sense, and some back and forth. So you don't want to have a lot of people reinventing a worse wheel. And then further distilling, it's like, okay, what is the job of a data platform team? How can you really enable your users? And I broke it down after thinking about it into two main categories. One is we should provide tidy packages, and the other is we should provide building blocks. So a tidy package is, here's something that just does exactly what you need. It's tailor-built for it. And the building blocks are, I don't know exactly what you need, but here's a bunch of components that you can stitch together in whatever way you need to get your job done. So an example of this is for the tidy package is the big data portal that we started a little over a year ago. And this is, if you want to interact with our data platform from like an interactive fashion, then you go to the big data portal. And from here, you can query Presto or Hive or execute pig jobs, or you can look at the schema of different tables, or you can look at data lineage, or you can see what's running on the cluster. All sorts of capabilities that you just go to this one place, and you don't have to worry about CLIs and client software installs, et cetera. You can, after executing a job, you can kill the job, you can see the details of the job, you can save queries, you can share queries with people, and there's also, there's no way you can see it back there, but there's a little information button, and in that, it shows you, here's the actual code that is being executed for any operation you're doing on the data portal, and the beauty of that is that someone can take that code and they can do whatever they want with it. They can now stitch together. It's the building blocks that let them do that same code in their own fashion to meet a somewhat different need. So instead of just querying the data, this particular case is, let's see, it depends on how you want to count lines of code, but it's 6 lines of code or 3 lines of code, depending on how you want to look at it. 3 lines of code that let you import a module. Craggle is our big data API, these building blocks that I was talking about before. We execute a Presto job. We say, yes, I want the headers, I want to execute it, and then I'm going to load it into a pandas data frame. And if you know Python, now you can do all sorts of manipulation. And this is running within a IPython notebook. And this is a really cool environment for interacting with your data platform. So we've sort of given the plumbing, like a low-level access to the plumbing here. And actually, we recently added IPython notebooks into our big data portal. So it uses Docker containers, and you spin up your IPython notebook, and it persists the results to S3 at the end. So you don't have to worry about all that stuff. But it's a mindset of saying, provide the tools for someone to do it in an easy fashion. So the last major topic I wanted to get into, which is just old hat to me at this point, is get your head in the cloud. But I imagine some of you are still not in the cloud. It seems so obvious to me. But there are reasons that it's hard to get out of where you are. And I think over time it's going to be less and less relevant to be in a data center. So the big thing is cost for a lot of people. Is it less expensive? Is it more expensive? If you're thinking about cost as your primary driver, you've missed the boat already. It's not that cost is unimportant, but it should not be the leading driver of a decision to go into the cloud or not go into the cloud. The reasons to think about it, first off, elasticity. So it lets you grow naturally if you're in the cloud. Like Netflix has exploded over time. And the problem is if you're in a data center, you either have to pre-buy a whole bunch of hardware that you may not need, which is very inefficient, or you don't buy enough, and then you're really screwed when you need it. So that's dangerous. The cloud helps mitigate that. It lets you deal with spikes a lot better. You can provision more hardware on the fly if you need, including spikes you create yourself. So suppose you get behind in your ETL and you I just need a little more processing power. You can spin up some more machines. Now, a big misconception, though, on the cloud is people often think it's all fluid. When I need hardware, I get hardware. That's actually not how it works, at least in Amazon. Almost all the hardware we use, we reserve 24/7. And it's a cost consideration. So if you use the hardware most of the time, then it's actually cheaper to reserve it 24/7. So it creates other interesting challenges and opportunities for us. By reserving it, we have all this hardware, and what we do is in the middle of the night and the morning when people aren't streaming as much, we repurpose that hardware that we've already reserved and paid for, and we use it for encoding movies or for calculating algorithms or doing batch processing. So for other people, that's sort of like a spot market. So some people, a spot market is, you can say, I'll pay just a little pennies on the dollar for instances, but they may go away. We don't use that very much because we have all this extra hardware that we've bought because we've reserved it. But this is a good way that if you say, I can't spend that much money, and as long as you're persisting your results as you're doing your calculations over time to something, so if the instances go away, you don't lose all that work, then this can be a very cost-effective measure. Services is another huge part of Amazon. It's not just about hardware. If you're thinking just hardware, you're doing it wrong. So we have EMR and SQS and S3, that's Elastic MapReduce, Simple Queue Service, Simple Storage Service. You have all these services that when you need them, they're ready for action. You don't have to negotiate with a vendor or, oh, I need it now, and you don't have it. If you never need it, you don't have to pay for it. It's just they're there when you need it. And it really lets you focus on your core business. Another is around redundancy and global presence. So multi-data center is huge. And when you're designing for the cloud, you should be thinking about multiple data centers. In Amazon parlance, it's called availability zones, but it's basically like a data center. Where all of our systems are built to work across data centers. So Cassandra, our Cassandra cluster runs in essentially three data centers. Every single cluster, it's broken up across those three. It also lets you go internationally so much more easily. So when we went to Europe, we just spin up stuff in Amazon. It's the same pattern we're using in the US, as opposed to dealing with like tariffs and legal considerations and how much hardware should I buy. We just spin up in Amazon. So the flip side is why not? Why not do the cloud? And this is important. The first is if you're just going to struggle internally, like if your company can't wrap your head around it and it's all about security, 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 blah, 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 then fix that first and then figure out the movement to the cloud. And you also, if you're going to get to the cloud, you have to do it right. So don't just take your data center stuff and forklift it to the cloud. You should have a self-service model. If you have like committees that approve every hardware decision, someone can't spin up a test environment, you're not going to get as much out of the cloud. Just make sure you hire adults that are responsible and they should be accountable for what they do. You should use distributed systems. It's a better design anyway than vertically scaled systems typically. So if something fails, it can fail over. You can do new models of interacting with your hardware, like red-black deployments is something where instead of, if you want to upgrade your clusters, you have your old cluster, your red cluster, you spin up your new cluster, your black cluster, and you slowly switch traffic over to the new one. And if things go wrong, you can just switch it back to the old one, and you can just blow away your old one when your new one's up, or blow away your new one and go back to your old one if it's bad. You can't do that in a data center unless you have double the hardware, and so on. This could be a presentation in its own right. Specialized hardware would be another reason why you might need to be in a data center, but this is becoming less and less relevant, and it's, if that's what's holding you back, then you should probably get out of the specialized hardware. If you're so big that you're bigger than the cloud provider, not that many of you guys are. We're pretty darn big, and we're not too big for the cloud, so it's not necessarily the best reason. And then back to cost. Is it more expensive? Is it less expensive? For us, there's no question it is significantly less expensive, not to mention all the things that it's enabled that we could never have done before, which is opportunity cost, which we would have been paying all along. So with that, I'm going to leave you with the last bit of philosophy. I mentioned it before, the Netflix culture deck. This will blow your mind. I highly recommend you read it. I read this before I started Netflix, and I was like, whoa, like, this is either like the best place in the world to work and it's super empowering, or this is going to be totally scary. And it really depends on how they put it into practice. And there could be some tips and techniques you could use in your company. A lot of it, I guarantee, will not work at your place, but it is for sure going to be an interesting read. And that's it. Thank you. I'll be around for the next couple of days, so I'm happy. Come up to me, ask any questions. Challenging questions are always fun. Thank you.
Thank you so much.